Okay, hi guys, so in this lecture we'll be seeing more on RPDF and the graphs on the same. So let's get started. So first note is, so as per the quantum mechanics, maximum probability of finding electron of 1s from nucleus is, as we discussed in the previous lecture, was according to the derivation which we saw in the previous lecture was 0.529 angstrom. So as per quantum mechanics, maximum probability of finding electron of 1s from where nucleus from where nucleus is located, or directly from where from nucleus, is 0.529 angstrom. Okay, next just see a note here that for calculation of radial note, position rather, r of r would be 0, or phi would be 0, or phi square would be 0. Okay, and obviously where r is not equal to 0. Okay, so let's see some examples for 2s. We are seeing the graphs, so not examples exactly. We are seeing the graphs. Okay, so we have graph of first 4 pi r square r versus r, so it would be something like this. Okay, so number of peaks would be n minus l, and number of radial nodes would be n minus l minus 1. Okay, so this is positive, this is positive, so need not write positive here, it's implicit. Okay, so this is the radial node. We have already seen the formula for calculation of radial node. So for 2s it would be 2 minus 0 minus 1. Okay, so let's now see the graph for 3s. Graph of RPDF, which is 4 pi r square. So I actually missed one r square here. It is nothing but 4 pi r square r, which is nothing but RPDF, which we discussed in the previous lecture. R square r versus r, so it would be nothing but something like this. Okay, so number of peaks would be n minus l. N minus l is 3 in this case, hence first, second and third peak. Number of radial nodes would be n minus l minus 1. N is 3, l is 0, minus 1 would be 2. So number of radial nodes here would be 2. Okay, next let us see for 2p. So for 2p it would be, again we would be having 4 pi r square r with r. So for 2p number of peaks would be n minus l, which would be 2 minus 1, which is 1. Number of peaks would be 1, and number of radial nodes would be 0, and this would be something like this, 1 peak. Okay, so let's calculate for 3p then. Next, so for 3p the graph of 4 pi r square r square r versus r will look like something like this. This is the peak. So for number of peaks would be 3 minus 1, which would be 2, and number of radial nodes would be 3 minus 1 minus 1, which is only 1. So this is radial node. Okay, so next, actually, if we see the maximum value or the maximum distance of the x-axis from the peak is the r max, for which the density is maximum. So let's see that point as well in this lecture. So suppose we have the graph for, let's say, 3s orbital, graph of RPDF, which is 4 pi r square r versus r. So we define the graph as so number of peaks here would be n minus l, so 3 minus 0 would be 3, and number of radial nodes would be n minus l minus 1, which would be 2. 1, 2 and 3. Redrawing it. So this is the r. So here the probability density goes to maximum, hence this is the r max. Okay, similarly for 3p orbital we can calculate the same. So for 3p it would be something like, again we are saying graph of 4 pi r square r with r. So it would be, for 3p it would be number of peaks as 3 minus 1, which would be 2, and number of radial nodes would be 3 minus 0 minus 1, which would be 2. 1, sorry, here is 1, yeah, so it should be 1. Okay, so it would be something like this. So this would be the r max at which RPDF is maximum. Okay, so next let's see for 3D orbital. So for 3D orbital it would be something like, with r. So for 3D number of peaks would be n minus l, would be 3 minus 2, which would be 1. Okay, and number of radial nodes would be n minus l minus 1, which would be 0. So this would be the graph, and this would be the value of r max. So r max here would be nothing but of the order of, so the r max order would be 3s would be more than 3p, that would be more than 3d. Okay, because as you can see that for 3s it r max was here, this was for 3x, for 3p it would be here, and for 3d it was here, hence r max order would be like this. So more the value of r, less with the value of r max. So more value of r implies less value of, or rather more value of l implies less value of r max. Okay, so with this we come to the end of this lecture. We will be seeing more on the same in the next lecture, more on RPDF.